Hey teammates, this is a tutorial of how to calculate the molar mass of a compound. Okay, today your aim is to calculate the molar mass of a compound, and I'm going to show you how to do that. So you can rewind this as many times as you'd like. You can repeat this as many times as you'd like, as long as you got it, all right? So I'm going to demo for you or instruct you on how to do this step by step. So I want you to look through your classwork really fast. Right now you have this periodic table of elements. The periodic table, you're very familiar with it because you went over it in 6th grade. And with that, you have the atomic symbol. So for example, hydrogen, the atomic symbol for hydrogen is an H, okay? The atomic mass is a number that you see at the bottom. The atomic mass for hydrogen is 1.008. Just round that to the nearest whole number, okay? That's what you're gonna do for this. Round it to the nearest whole number. So 1.008 rounded to the nearest whole is 1. So I would use 1 for hydrogen. And then that's like the main thing that you need to know, because at the bottom is like the actual elemental name, and it's really cool to know that as well, all right? But for the sake of calculating the molar mass, the only thing that you need to know are the symbol, the atomic symbol, as well as the atomic mass, all right, in each square, okay? So I'm going to be referencing this a lot, like the whole entire time. And what else I'm going to do is reference like this next sheet. This is like a step, like demo of how to actually calculate the molar mass. This may look pretty tedious to you and a lot. However, it just looks that way because it's all spaced out in this like graph, in this table. It's not going to be that hard. I promise you, it's all you're doing is adding and multiplying. It's really not that difficult. And this is just like a very instructional like overview of how to do this, okay? And we're going to be doing this right now. And then the next pages, like the next 2 pages are your actual worksheet. So this is what you're going to do, calculate the molar mass. You're going to calculate the molar masses of this guy, okay? Cool. So something that I want you to write down on your paper, you can write it down like in this top portion right here if you'd like to, like right here in the empty spot with your name. I want you to put the like definition for molar mass. So everyone should be writing right now. If I see this on your screen, you're writing down, okay? You write it down right here. I'm gonna write it down on the board. Okay. So the molar mass, I'm gonna write it right here. Molar mass is, I'm gonna put an equal sign. Molar mass is the total atomic mass, right, of a compound. And that is the total atomic mass. So for example, if I had an H for hydrogen and an Li right here at the bottom for lithium, if I had an H for hydrogen and Li for lithium together, I would add the 1 hydrogen and the, let's see, rounded to the nearest whole number, the 7 for lithium. That would give me 7 plus 1, 8. My atomic mass is 8. That's the molar mass. It's that simple, I promise, okay? So I'm gonna work through a few with you. You have this definition, total mass. Mass is like a number, the amount, all right? If you want to, if that helps you out a little bit more, okay? The amount, all right? Okay, so I'm gonna work you through this first one right here on this page, okay? All right, it's right here on this page, this first one right here, okay? You don't need to know the name of this element, but this is barium nitrate. We're gonna calculate the molar mass of barium nitrate, okay? So, barium nitrate has 3 elements, right? Ba, capital B, lowercase a. I know that's one element because it starts with a capital letter and it ends with a lowercase letter. And I see an N and an O next to that, right? You see that, it's in your paper. How many elements are in NO? There are 2. because it has two capital letters, as you can see. Capital N, capital O, okay? So there's actually two elements there that are close together in that compound. So N is one, O is the next one, okay? Any other elements? No, there are not. Okay, so it's just Ba for barium, N for nitrogen, O for oxygen. Now we're going to count how many atoms there are, okay? So for atoms, we know that a subscript, okay, the subscript, people that had data day with us last time know what a subscript is, but it's that like small number, write this down, small number next to an element. It's a really small number. So for example, barium nitrate, the 3 and the 2 are subscripts, okay? The subscripts tell us how many atoms there are of that element. So how many elements there are. So the subscript tells us how many elements there are, all right? So tells us how many elements there are. Cool. We should write that down. All right. This will also be on the board. I'll keep it on here for you to see. Okay, I'm recording this the day before. All right. So now I have my periodic table. I know what an element is. I know what a compound is, and I know what a subscript means. Okay. So let's start to calculate this out. Barium. How many atoms are there of barium, of Ba? Well, I don't see a subscript next to it, so if it's just by itself, that means that there is one. Okay, so there is one atom of barium. Okay, I put it there, and you can actually see it. I'll move it a little closer so you can see. Sorry, my shoes are slippery. Okay, one atom of barium. Right, so I wrote down atoms here, atomic mass in total. Cool. All right, now nitrogen. How many atoms of nitrogen are there? Well, with this, we're using process of distribution. Okay, we know that from math. And I also wrote it here on the board. Oh, I wrote this backwards. So there's NO2, that's actually nitrite, NO3 and 2, yep, nitrate. I'm distributing the 2 inside, anything inside the parentheses is distributed by the 2. So I'm distributing the 2 to the N, distributing the 2 to the 3, okay? So that means for N, nitrogen, there are 2 of those because the process of distribution. There's 2 because there's a subscript outside of the parentheses. Okay. So for nitrogen, there are 2 atoms. If this is confusing to you, stop the video and watch it again. Okay? All right. And then for oxygen, so I have a 2 for the subscript right next to it. I have a 3 already inside that oxygen, okay, right next to the oxygen. Well, whenever you have things like that, guys, that means that you have to multiply, okay? So 3 times 2 is 6. Okay, so how many oxygens do we have? 6. Yep, super easy. Whenever you see 2 subscripts next to each other, right next to each other, and closed off by a parentheses, you multiply, okay? So there are 6 oxygens, okay? Now, what's the atomic mass of barium, of Ba? Well, I'm going to look at my periodic table, because I have it. All right, Ba, I'm looking. Where is barium? It's right here. It's in the second column, okay? It is 137.33, rounded to the nearest whole, 137. Okay, so atomic mass of barium is 137. Okay, nitrogen. What's the atomic mass of nitrogen? Here it is in the 15th column. It is 14.007. So rounded to the nearest whole, it's 14. Oxygen, right here, it's right next to nitrogen. It's 15.999. Rounded to the nearest whole number, I'd say that's 16. So it's 16, okay? Now, there's your chart, nice and neat. what you're going to do is multiply it all out first and then add. Okay, so 1 atom of barium times 137 atomic mass is 137. Okay, and now the next one is 2. I have 2 nitrogens times 14, because that's the atomic mass of nitrogen. I put a little multiple symbol there. 2 times 14 is 28. Okay. And then this one, 16 times 6. Okay, 16 times 6. 6 times 6 is 36. 16 times 6 is, yes, 96. If it takes you a while, it's okay. I'd rather you do it right than rush, all right? At least for now, because we're learning. So those are the totals of each element that we have, just of each element. The next thing we have to do is find the total of the compound, okay? To do that, we add. We add the totals, 137 plus 28, and then all of that plus 96, okay? So I'm gonna have you try that. 96 plus 28 plus 137. What's the total? Let me write down total is, did you get 261? That's what I got. And there box my answer. Okay? Cool? Okay. If you don't know how to do this, go back and rewatch this. Make sure to work through it with me as you watch it. Okay? Cool. All right. The next thing I'm going to do is to work out the next problem with you. Okay? So that was the demo of how to do this. The next thing is I'm going to work on this guy with you, okay? The molar mass worksheet. So you're gonna go to your next worksheet. Go to your next worksheet, okay? And go to the, actually I'm gonna show you on this video. So yeah, go to the next worksheet and we'll do it right now, okay? I'm gonna scooch this over. Ta-da. All right. Use this as guidance, please. Use these terms as guidance, please. All right, I really need you to do that. The next thing that we're gonna do is actually work this out, okay? So we're gonna find the molar masses of the following compounds. Let's start off with number 1. This is Li, capital L, lowercase I, capital I. All right, I wrote it down for us already. This is a lithium iodide. Do you need to know the name of that? No, it's not important right now. We're just focusing on calculating the molar mass, okay? So, for lithium iodide, we're gonna do the same thing, where this one's a little more simple. So I gave us a hard one. So this one's simple, so we draw our chart. If you need extra sheets of paper, just let us know, okay? I'm gonna do the elements. And then I'm going to do another column of the atoms. You can do this with me. I'm going to do another column of the atomic mass, which we find on the periodic table. And I'm going to do another column for the total for each element, just element, okay? All right, let's figure out how many elements we have. Capital L, lowercase I, stop. I know that that's one element because there's a capital letter right next to it, so I'm going to stop it, all right? And I'm going to put Li here. Okay, I'm going to make a column. The next element is what's left, which is the I. Okay, that's iodide. Cool. Super simple. Next thing we do is find our periodic table. Okay, and look up Li on the periodic table. Li, we did it earlier. I see it. It's right here on the left side. It is lithium. Okay. The atomic mass for lithium, it says 6.94. Rounded to the nearest whole, I say 7. Okay. But first we need to do the number of atoms. The number of atoms for lithium, I see no subscript, so it's just 1. I mean, if it's there, then there's actually 1. If it was 0, then it wouldn't be there, okay? So make sure you always put a 1 if there's no subscript. Okay, and then for iodide, there is just 1, so 1, okay? Cool. Atomic mass of lithium, we did it at 6.94, rounded to the nearest whole, it is 7. Atomic mass of iodide, iodide is actually on the far right side, okay? Atomic mass is 126.90, rounded to the nearest whole, 127, yeah, 126.9, 127, okay? Now what do we do? Calculate the total. Yes, calculate the total for each element, okay? So 1 times 7 for lithium is 7, okay? And then 1 times 27 for iodide is 127. And now we add. So the total, 127 plus 7 is 4, 3, 1. Did you all get that? 134, okay? Get it? Cool. All right. That's it. I'm going to let you do it by yourself. If you need any more assistance, raise a silent hand, and Ms. Lopez and I will help you, okay? You can watch this video again if you need to. You can rewind it, you can pause, and then work it out to make sure that you get the answer. All right, and we'll just be around to help you out, okay? Let us know if you need anything. Good luck.